That's fine. Okay, our goal today is to start reviewing for your gold packet quiz. We're going to talk about simplifying radicals and types of numbers today. What I have planned for this week is Thursday you're going to have a quiz, which that's the last day I'll see you guys because Friday the basketball game, 8th and 9th period. So Thursday you'll have a quiz. I'm in the process of typing it, so I'll let you know possibly tomorrow how long it is. It shouldn't be that bad. But just types of numbers, just simplifying radicals. If you're not going to be here Thursday, you need to let me know in advance so I can have you take it Wednesday or whatever. Kyle? Probably. I was last year. Okay, so anyway, that's one of our goals. Today I need to finish up going over the Keystone questions from Friday. You'll have some type of graded assignment this week, not a quiz, but a graded assignment on some Keystone questions. So I need to finish going over those. I ran out of time Friday with you guys. So we'll do that today, plus start to review radicals and types of numbers. Okay? I have a stapled worksheet we're going to use this week. So if you're not here, make sure you see me in homeroom. That I'll give you guys. You're just going to do part of it, though. So basically, this week is just reviewing radicals and types of numbers and making sure you're okay on the Keystone 1 and 2 combo. We won't move on to the next chapter, which is 3 and 6, until after break. Brian? I'll tell you that later. I already said that once, but I'll say it again later. Eric? Do you have a question? You're more than a week ahead. Okay, so let's start with our warm-up, then we'll go to the Keystones. So natural numbers. Thank you, Brian. Who can tell us what natural numbers start with? Nathan? Good. Sorry. And what kind of numbers are natural numbers?
They're positive whole numbers.
Good. So they are positive whole numbers. It goes all the way up to infinity. Okay, just as a review. Gigi, whole numbers start with? Awesome. So all nice numbers, it starts with 0. It goes all the way up to infinity. Luke B, what is an integer? Good. So also a nice number. All the negatives, all the positives, no decimals, no fractions. Okay, rational. Eric? Good. Good. So fractions, mixed numbers. Fractions, mixed numbers, any natural whole integer, a perfect square, improper fraction, can't think of what I missed. Anything that's nice and also is included on this side of the chart so far. Gigi? You want to do the next one? Okay, irrational, go ahead. Good. So this one is this one, the number repeats however once. The perfect example, like Gigi said, is pi. It repeats however. Yes, we know that pattern to a certain decimal point, but there's not a pattern. We just know the number to a certain point. If you had square root of 25, would that be rational or irrational? Nathan? Good. Rational, that's a perfect square. If you had square root of 13, which one would that be? Lucy? Good. Irrational. Nope. You take the square root of that, it's not going to be a nice decimal. It just repeats however. Real number is anything on the left side. Everything is real unless, who can explain this one? Ryan C? Good. So if there's a negative inside the square root house, such as square root of negative 10, imaginary. All you need is a negative inside here to make it imaginary. Gigi? Yep. Yep. I'm getting so far with you guys so quickly. We're going to get to that soon so I can actually teach you it so you can see how it works. But you're exactly right. Good job. Okay. Anyone have questions or comments on how to categorize or what types of number are based on the definitions? Okay, let's start with square root of 25. Who can check off or X off whatever you put on your paper? Brian C? Good. Negative 3.1, Eric? Good. Jared, negative 12. Good. 1, Luke C? Good. 0, Gigi? Good. Kyle, not the blank one. Square root of negative 16. That's okay. Oh, careful. If there's a negative inside. Good job, Kyle. Kyle, are you sleeping back there? I'm just kidding. It's Monday. Thank you. Good. Okay, so Kyle, I know you won't forget that on the test. You guys remember Kyle when you see the negative inside, imaginary, okay? It's not absolute value, it's square root of a negative, so imaginary. Brianna, square root of 110? Square root of 110. Is that a perfect square? Irrational, real. If you take the square root of that, it's going to just repeat, however, doesn't have a nice pattern. Okay, questions on the warm-up. Okay, let's go to your piece of paper or notebook for a couple minutes. I want to switch to the Keystone questions from Friday so I can make sure I answer the rest of your questions for a couple minutes. And then we're going to come back to simplifying radicals just so I could do a couple examples with you guys. Okay, let me just quickly go through these. Is everyone okay with median? Just give me a head nod this way or this way. Okay, you don't need to say anything, just head nod. How about mean? Just go this way or this way. Okay. No. How about GCF? Give me a head nod this way or this way. Okay. LCM? Yes, foiling, I'm sure, right? Foil, right? Twice foil. Okay, functions? AC grouping? Okay, here's the ones where I think ignore that. Okay, here was the Keystone Quiz 1-2C. I'm pretty sure someone asked me about this one and it was the end of class. Yeah, that's, okay, thank you. Okay, so on this one, if you want to write something down, go ahead. If you're okay, just sit there and listen. You'll see this again this week. I'm going to give it to you in some type of graded assignment. No more quizzes, just some kind of graded assignment we're going to do. Okay, so the first part is, I know you guys already read this because you took the quiz of this on Friday. First part is you need to find how many total students are at the high school. We know there are 700 freshmen. We do not know the total amount of students. We know 16% of the school represents freshmen. I explained the proportion method on Friday. A over B equals P over 100. Part over whole equals percent over 100. So Nathan, you with me so far? Did anyone else need this problem? Couple of you guys. Okay. Okay. So the total amount of students at the school, and I'm just jumping ahead here, after doing cross products, which is like, remember, a butterfly with no head, multiply across, then divide, you get 4,375 students at the school. Okay? So that's step one. Is everyone okay? Okay, step two, take the total. We now need to find how many seniors are at the school by using the information in the pie chart. You know there's 29% or 29% of the students are seniors. We found the total, so we now have the B part of our proportion. When you solve for the seniors here using the proportion method, you end up with a decimal, and I know you can't have decimals when you're talking about people. Just for now, keep that there so you can make sure that your answer is as exact as it should be. Okay? So that's step two. Step three, you need to take this number, and now we need to figure out if 81% of the seniors are enrolled to be in college next year. We need to figure out how many of the seniors at the school are actually going to college. You take this number and multiply it by the percent, or you can use the proportion method again if you want. I usually just take this and multiply it by 0.81. I think that part's a little bit easier just setting it up like that. Your call. You can use the equation method or the proportion method. It's completely up to you. I taught you guys both methods last year, so your call. Anyway, you end up with 1027.68, which is just 1,027 was the answer. So just round down or up, depending on what answers they give you. There will just be one answer that's the closest. Brian, see, you okay with that now? Nathan and Brianna? Okay. Anyone else that had questions on this? Do you still have a question? Okay. Number two, I did not get to this one. Did anyone need this explained? This was a common denominator problem, some of you guys. Okay. So when you see problems like this, all I want you to do is to focus on the denominators. Ignore the numerator. You're not concerned about that at this point. They're asking you what the denominator will be. I want you to think of least common multiple. You're technically finding the least common denominator, same thing as least common multiple. So if you look at each of these, the 2, 4, and the 5, what's the smallest multiple that they all have in common? Kevin? Good. 20 is the smallest multiple that they all have in common. If you have trouble with that, take the larger number and first ask yourself, do 2 and 4 go into 5? No. Then go to 10. 10 is not a multiple of 4. Then go to 15. 15 is not 4. 4 does not have a multiple if it's 15. Then go to 20. So if you just count by 5s, finding all the multiples of the larger number, that's a little shortcut for you. So is everyone okay with the 20? Now, in regards to the variables, you need to have every variable represented. This is a little shortcut. And then take the largest exponent of all the variables that are there. For example, the x's, they both have 2's, so it has to be x to the second. For the y's, the largest exponent is a 3, so it's just going to be y cubed. And then the z, the largest exponent is a 2, I believe. Yeah, is a 2. So I couldn't see what that was. So take a 2. That's your LCM or least common denominator. Same thing. So a little shortcut is take all the variables that are represented and then look at all the variables that are there, take the largest exponent. You guys all right with that one? Okay, it should be easy. Again, the more we do them, I think the easier it'll be. Okay, number 3, I'm not sure if anyone needed this one, the one with the radicals. You can just throw this right into your calculator, Brian. You did? Okay. Okay, anyone else? I know who I'm talking to here. Have you, the rest of you guys, are you all putting this in your calculator? Yeah. The easy, okay. All right, so Brian, see, let me at least show you one of these. For n equals 2, I want you to take your calculator, type in second square root of 2 raised to the, what's the first one, second power, and then square root of 2 raised to the 4th power. Tell me what you get. Yeah, you can put multiplication between it, or you can just leave it as just right next to each other. It doesn't matter. Okay, try it again, though, just to make sure. And do you understand where I'm getting these numbers from, Brian? Okay. Good. So this one's 8, which is correct. This one ends up being 4. You're finding the difference of them. The answer's 4. Easier? Okay. So put that in your calculator, put that in your calculator, subtract them. Okay? All right. Anyone else on that one? Okay, the bean problem. I know I've went over with you guys before. Does anyone still need some explanation on this? Anyone else? Brian V, are you okay with these now? Because I know you initially. Okay. All right, so first step. There's 200 uncooked beans in 1/12 of a cup. So the first thing you need to do is take those 200 uncooked beans, figure out how many are in 1 cup instead of 1/12. Multiply by the denominator. Okay, you get 2,400. You with me? Okay, and then step 2, we know that the bean expands approximately 8 times its uncooked size. This is going to expand. You need to divide this by 8 to figure out how many are going to be in 1 cup, how many cooked beans are going to be in 1 cup, because that expands 8 times its size. Okay? And then the total number of cooked beans, which is right here, is going to, we need to figure out how many are in 4 cups, not 1 cup. So take that 300. Multiply by 4, you get 1,200 are in 1 cup. Okay, sure? Okay. If you know those steps, it'll make it much easier. Eric? That's fine. That's fine. As long as you understand what you're doing. There's a lot of ways to set these up. Okay, next one. How about this problem? And again, you took this Friday. We've done a lot of practice with these, okay? How about this one's a little different? Okay, good. Okay, how about GCF LCM again? Okay. And then the last one is just factoring by GCF. So when they ask you about the factor, it could be either the GCF or what you're left with inside parentheses. Does anyone need either part? Sure. Okay, so the graded assignment this week should be easier, do you guys think? It'll be very similar to 1 and 2, but I just changed the problems a little more. Okay. All right, you guys, actually leave that paper out. Let me go to, actually no, you can put that paper away. Let me give you this. I want you, when you get this paper, flip to page 2, please. Put your name at the top and then flip to page 2. Again, if you're listening to this and you're absent, please see me in the morning so you can get this paper. No, this is not hard. I know, I decided I would tell them again, Jared, thanks. They're going to be annoyed when they listen to this. Okay, sorry. Oh, Brian, so if they're absent, we can't talk to them if they're absent. All right, put your name on this paper. Hold on, Kevin. Okay, flip to page 2. I have golf pencils over there, Gigi. You can, I said. Okay, flip to page 2, please. And I want you to take a look at number 1 with me, please. Okay, flip to page 2, and I want you to take a look at number 1. I want to do just a little short review with you guys of simplifying radicals. Okay, so in general, when you're simplifying radicals, what is the goal? What are you trying to do? Well, what's the goal? Okay, that's okay. Nathan, what's the goal? Okay. Okay, how do you do that? What's the first thing we have to do? Brian C. Okay, of what though? I'm trying to get you guys to say a certain word. Begins with a P. We're trying to find what? Andy? Good. We're trying to find all the perfect squares, including variables. Gigi, there's golf pencils over there if you want one. Okay, so number 1 is really easy. This is already a perfect square for you, right? Square root of 100 is 10. So number 1 is really easy. All you're doing is taking the square root of that, and your answer is 10. Okay, let me go to a harder one. Let's go down to number 15. Guys and girls, you should not be yelling out. Kevin, face the smartboard. Okay, 15 is square root of 243, m to the 5th, n to the 2nd. So here's how I usually teach us and how I taught this to you last year. I ask you, what is the largest perfect square that goes into 243? So can anyone figure out what's the largest perfect square that goes into 243? Kevin? That's 15 is not a perfect square. Brian? No. It has to be divided into it, Brian C. So something times something is 243. Nope. That doesn't divide into. Well, good, thank you. So 243, I want you to break this down like I am. You can change to square root of 81 times square root of 3. Now, do you have to choose the largest perfect square that goes into it? No, but it makes it much easier for you. 81 is a perfect square because when you take the square root of it, you get a nice number. You guys remember perfect squares, right? Okay. Now, a variable. When is a variable a perfect square? Who can raise their hand and tell us? Gigi? Awesome. When it's an even number. So who can tell us how to change m to the 5th? How can you break that down? Nathan? Good. We're splitting it into m to the 4th and m because when you multiply same base, you add exponents. So there's a lot of rules in here you need to remember. The n to the 2nd, leave alone because that's already to an even number, so that is a perfect square. Okay, we are now going to circle all the perfect squares. Is everyone with me? Okay, 81 is a perfect square. Bless you. M to the 4th is a perfect square. And n to the 2nd is a perfect square. So circle all the perfect squares. We're now going to take the square root of them. The square root of 81 is 9. What's the square root of m to the 4th, Kevin? Good. Divide the exponent by 2 when it's an even number. So m to the 2nd. And then, Brianna, what's the square root of n squared? Good. N. With the radicals that are left, which is square root of 3 and square root of m, just kind of mush them together, write them inside the same radical. That's the answer. Give me a thumbs up, thumbs middle, thumbs down. Do you remember that from last year? I know you watched, some of you watched the videos, but. Okay. Brian C. That's fine. You can do that. It doesn't matter how you do it. And that's basically what we did, Brian. The numbers are here and the variables are here. Whatever process you prefer is fine with me. No, it's not all homework. Give me a second, Kevin. Kevin. Does anyone have questions on radicals? Okay, here's what I want you to do for homework. Just pages 1 and 2. Okay? It should not take you very long. Please don't lose the packet. I want to use this packet in class tomorrow. Okay, all you need to worry about for Thursday's quiz are types of numbers and radicals. So it shouldn't be that bad for you guys. But you will have one graded Keystone quiz, not quiz, some kind of assignment in class. I don't know when, either tomorrow or Wednesday. Okay? And you probably won't have homework over break. I'm guessing. We'll see how things go this week. Okay, we have about 4 minutes, so go ahead and get started on your homework. They would not.